Alright, welcome to the video. This is going to be a video about this character controller that I've been making in Godot for a little bit. And yeah, I'm going to post a bunch of links in the description because a lot of this stuff I got it from other people on YouTube. And I think it's better if you just go watch their videos for certain portions of this because obviously I'm not the one that created whatever it is that they made, and I just copied it. But let me just show you right here. Let's get started with the character itself. I used a node. Well, I made a new scene for it, and in that scene is a character body 2D node. So it's just the character body 2D node. It's grounded because this is a platformer. I think this is pretty regular stuff here. I think the snap length is the only thing I changed because the character was bouncing when he was going down a hill. It fixed it. I'm not sure if this is a permanent fix, but so far it works. And moving platform, I'm actually having a problem with moving platforms still, so don't take this too heavily. Everything pretty much normal there. So it's a character body 2D node, and then make a collision shape as a child of it. Put this is the dimensions of that one if you want to copy it. Make a folder and put these things in it. So I'm going to show you right now. I'll get this one for example, the crouch shape. I'll show you them all, but the one that I just showed you right now is the standing shape. It has these dimensions. You can use the same dimensions I'm using if you want to follow the video, but for this video I am using like 3 different colliders that I'm going to switch between because he has the standing, crouching, and then prone, like lying down. And then the way you save one of these is by setting the dimensions that you want first, and then clicking here and then click save as, and then put them in this folder and then name them whatever you want. So do that for the standing shape, and then do that for the crouch shape. This is the dimensions of the crouch shape, and then these are the dimensions for the prone shape. You can have them any dimension you want, but if you want to follow, just make it like that. But I do need 3 different ones for this tutorial. I'm going to change it back to the regular one for now. And, okay. So once you've done that, you have the body collider, okay? There's also this other collider called ledge grab. It's just a rectangle, but it's just one line. As you can see the dimensions. That's going to help you grab onto the ledges. I got that from a tutorial video on YouTube. I don't know if I like this solution because it brings some peculiar behaviors, but so far it works. Put it right there. Sprite 2D handles the character. This one is I don't know why it's stuck on that one, but there's other ones as you can see right here. It could be any sprite you want. Let me know if you want me to put this on the download or whatever. The camera 2D, child of the character body. The canvas layer, you don't need this for right now. So this you don't need either. Forget about that. But we need this. Make a node 2D, call it wall raise. Then as a child of it, make 6 raycasts. Position them like this. So I'll show you right here, the top right, as you can see right here. Put it at the top right of your collision box. Then the middle right, make it longer, but put it in the middle, and then face it out that way. And then the bottom right, make it the same length as the top one and put it at the bottom. And the middle one, make it as long as you want to be able to climb on walls, like the maximum angle of wall that you're able to climb. And I mean that because in my script, I'm going to be checking, as you can see it's 45, right? So I'm going to be checking if this raycast is colliding and the top or the bottom is colliding, then come into the climbing state. That's going to be for climbing walls. And so yeah, I showed you the right side raycast. Just do the same thing on the left side. Top left, middle left, bottom left. Put them just like this. And then after you make those raycasts, make another node 2D called step rays. And by the way, the node 2Ds themselves, I placed them at the, well, this one is at the bottom. The wall rays one is in the middle. Not sure actually if that matters too much here, but just follow along, I guess. This step rays node 2D will have two children. They're both raycasts. One is step forward, one is step under. The step forward one has to be here in the front, and the step under one will start right at the bottom of your collider and then go down. They have to be longer than the max step height, which is a variable in the player script that I'll show you very soon. And then just two other raycasts as a child of the character body, above head ray and ledge up ray. These ones are up here. Let me show you. So the above head ray starts at the bottom of the collider and make it 2 times the height of your collider. This is for checking above your head for certain things. Make it just like this, 2 times the height of your collider. You see it starts at the bottom and it ends right up here. And then the ledge up ray, make it start at the ledge grab collider, which is this. Make it start right at the same Y height, and then make it go up all the way to the same ending height as the this ray, the above head ray. So you can see how they line up right there on the top, and then this line right here lines up to the bottom of this ray, right? Okay, simple stuff, guys. Now, let me show you the scripts. So, make a folder, call it states, okay? Now, in that folder, make this script, state.gd. Let's open that. Here is the script. This is going to be the base script, which all the other state scripts will inherit from. And all you got to do for this script is, I think this comes by default because you're not supposed to attach it to any node. You're just supposed to create a script from scratch. Just put it in this folder, and it's probably gonna have that by default. And then make these two variables. I declared this in the other scripts that I'll show you. The tutorial that I followed to make this, he didn't declare the classes, but I did it just for type safety. I think that's what it's called. So just make variable states null, variable player null, and then make these functions: enter state, exit state, func update, delta, pass, and return null. They're not doing anything here, but we will be using these in the other scripts that are inheriting this script. And then, I don't know why, but, the tutorial I watched, he is handling the friction and the movement, the sideways movement at least, of the character in this script. So I just made this. You could copy all this if you want to, you know. move along with me. But it's friction, speed, and acceleration, which is going to be used in these move toward functions, which is going to smoothly and gradually move the velocity towards whatever you set it to. So it's always moving towards 0, but then once you click something, it's going to try to move against that, put it on the speed that you select. And that is going to be set down here in player movement function. This is just going to check if I'm on the floor, if I'm in crouch state, prone state, or if I'm in the air down here. And yeah, you can just copy all this. These variables I'm going to show you in a second. They're in the player script. But first, let's go to the state script. And now this is coming from this. So make a new scene first called states. Come to that. The states scene is going to have regular nodes, not node 2D or anything like that, just node, and call it states. This is in the root one, and then all the states that you actually want in your game are going to be children of the states node. The states node is going to have the states GD, right? So let's open that. What did I do? Yeah. So this is states GD right here. This is where I declared states class. And again, you don't need to do this, but I guess just following along. All you have to do in this script is get a reference to every child node, and just name them the same thing for sake of less confusion, right? Pretty simple. Just and this is how you add states. You make a new node, child of states, and you gotta remember to reference it here. And then we are gonna go to the player scene again, and I'm gonna show you the player script right here. This is the script attached to the character body 2D. So attach a script to that, and just make it bigger. This is the script, okay? So in this script, you're gonna be here. Just copy these variables down for now, and this is where I declare the class name, player class. Yeah. So these is a bunch of variables. Just copy them all down. We're gonna be using them, pretty much all of them, in this tutorial. Rather just explanation video. Yeah, just pause it and copy them. I'll move down. So copy these for the input, then copy these bunch of numbers that are going to be calculated right here. Then move down. We're going to be calculating these. Write all these just how you see them. And then these two, very important for the states: current state, pre-state, null, null. Make sure you type it just how it is, equals null, equals null. And then here, you don't need these. You don't need the arm or the attack box, and you don't need the animator or the sprite, unless you have your own, of course. Whatever. Just not going to talk about these in this video. And then reference those resources that we made earlier, which are the collision shapes, right? Standing, the crouch, and the prone dash check shape. You don't need the prone dash check shape. You don't need this one. Just forget about this one. But write down these three though. This you need. So then let's move on to the ready function. The only thing we're going to be doing here is setting the references that you need, and you're going to start the state machine off on states.idle. But first do the for loop for state in states.getChildren. Now this is, let me see, this is referencing the states node, which I forgot to say. You go in, remember we made this scene, right? It has the states node and then all the other nodes as children. You're gonna instantiate this as a child of the character body 2D. You just instantiate this scene here, right? And that is, what is this referencing? So for the state in states.getChildren, so the state is referencing the child of states, and it's setting here state.states equals states and state.player equals self, and what that is setting is these variables. This is going to be used in the scripts. This one is going to be used to reference all the children of the states, which is all the states, and this one is going to reference the player. As you can see, states is set as the node states, and then player is set as the self, the player node. And then here we're just starting off the state machine on idle. Previous state equals idle, current state equals idle. That's good right now for the ready function. Let's move on to this function. Make this function right here. Change state. So make this variable in the parameters. If input state is not null, previous state equals current state equals input state. So this is just moving it along. You know, the current state is now previous state, and the current state is the input state, which you put here. And then at the bottom, we're going to play exit state on the previous state, and then on the current state, we're going to put enter state. And as long as this keeps rolling along, which it will, it'll keep doing this in succession, and then the next state will play exit, and then the next one enter, and so on. And then you call this function here in the physics process function. So make a physics process function. Forget about all this other stuff. Just you know what? You can do this while we're here. Make this 2 lines as well, and actually, yeah, make these 2 lines, and that's just gonna clamp your speed. You could play around with that in your own project. The max speed variable that we made, just change that, and that's gonna be the max speed that your character can move at. Clamp. What the clamp does is tries to maintain the number in between these values. You gotta do it for both Y and X. And yeah, like I was saying down here, just put that change state function, call it in the physics process, and then for the parameter you put current state dot update, and that is gonna call this update on whatever current state you're on. And I'm gonna show you. I'll show you real quick. That is, for example, I'm in the climb script. This is what the update function looks like in the climb script. You know, it's checking everything, and if it's something else, it's gonna put you in a different state. So that's why the states change, because you're calling the update function every frame. So it's basically like another physics process, you know, basically. But for now, leave that like that, and I'm gonna put something else. So I'll show you this. Make this function, put it here, player input, and then I have that function all the way at the bottom, right here. So this is a lot of stuff to copy down. Just pop. You know what? Let me show you guys real quick. Sorry about this. Wow, I didn't think of doing this. Project settings, input map. Okay, guys. Copy this down if you'd like. So I have jump, climb, dash. The The dash, you don't need it. You can put it just for this tutorial, but move up, move down, move right, move left, attack, reset scene. I'm gonna move it down now. Remember, you can just pause it, and this is the rest of it. Crouch, down test, pause, scroll up, scroll down. You don't need these two. It's not for this video. But you, and this one either, drop. But you put slide and dive, and the other ones are good too. So pause the video and just copy it down. But you know, this variable is at the top of the script, and you'll set it here to 0, and then you know, change the .x and .y of it based on if you're pressing up, down, left, right. And then, you know, like I said, just pause the video. I'm gonna move it down here. You copy all this down. I'm gonna move it down and copy the rest down. That's all of it. Yeah, just copy it down. And once you have that, you know, remember, put this in the right here in the physics process. Call that player input. And yeah, while we're here, put this function here as well. Slide key hold. I'll show you right now. That function is above the right here. No. Wow. Hold on, guys. Where did I put that thing? Right here. So this function is gonna. I'm gonna change this later on to be more modular, because right now this only handles if you're holding or pressing for these specific functions. And you're gonna need these variables for this function. I'm gonna, like I said, this is pretty temporary, but it works for now. So just make these variables, make this function, just copy this down. This is basically it's checking. Let me see here. If action is pressed, slide and dive. So right when you press it, it's gonna press action started. It's true. And then if it keeps being pressed and action started, which is you just pressed it, and if you keep pressing it, it's gonna do add to timer every frame. It's gonna add one, I believe. And then if the timer is greater than or equal to the threshold time and action started, this just keeps it nice and safe, you know. This is the threshold time. You can change it. This is basically how long you gotta hold it for it to activate. If the timer is greater than or equal to threshold time, you know, you revert this back to false, change the timer back to 0, and then dive input equals true. Like I said, this is just for the dive and slide input, but I'm gonna change it later on to be modular, and I'll make another video, I guess. And this is checking for the slide. So if timer is less than threshold time and action started, slide input equals true. Then you just do this. Alright, so just copy this down. You know, so far it works. Alright. And now I'm gonna show you. Let's show you this function. So this function is part of the original YouTube video that I saw, and I'll put it in the link where he's showing me how to make the state machine. And then he also makes, mine is a little bit different than the original one, so you can just follow along with me. So get next to wall, and here you do for raycast in wallraise.getChildren. Remember, wallraise is the node 2D, which has all the those raycasts as the children. 6, one's for the right and one's for the left. And for each of those raycasts, it's gonna force the update. I'm not sure if I'm doing this in the correct order. If you know anything about it, let me know in the comments. But here we're gonna do. Well, this is gonna check if the middle left raycast is colliding. then it's gonna check if the top left or the bottom left is colliding. And if it is, we're gonna set the previous wall direction to whichever side it's on. So left, it's gonna be vector 2 left, and then we're gonna return, function itself will return vector 2 dot left. So basically, and then we're doing the same thing for the right side. So if middle right is colliding, we check if the top right or bottom right is colliding. And if they are, we do the same thing. But right instead of left. And then at the bottom we return null. If nothing else happens, we return null. But you know, I'm sure you understand. This is this is for the climbing state. So we'll get you into the climbing state, and I'll show you that in the script. A few minutes. So it's gonna be if the left one is colliding, and then it has to be either one of the top or the bottom. So it has to be one of the middle ones. It has to be the middle ones for sure, and then either top or bottom, but it has to be one or the other. That's how you do that. And then, yeah, copy this one too. This one, I'm gonna change this in the future, but so far it works. Okay. Hold on. It's like a bug. I'm like sitting outside, but. So just copy this down. This is gonna be for to prevent you from getting into the dive state. There's not enough space. To copy this down. This is just gonna check both middle raycasts on both sides, and if they're both colliding, it turns true. And then copy this one down. Get above head. I'm gonna make a new video later on, because I heard it's better to use enums instead of strings. But for the sake of this video, we're just gonna use strings right now. I'll update it later. So this is gonna check the above your head. If above head ray, which should have copied from the top of variable list. If you haven't, just go back in the video. I paused to see all those variables. But this is a ray, and if it's colliding, then we create this variable diff, and we're gonna use this. Let me show you this real quick. This is at the top of the script, and it's gonna be, call it ray collision to origin. Not sure if this is a good way to do this, but it works. So you just do, put this in the parameter ray and make it a raycast 2D just to be safe, and then it returns a float, and it's gonna return the ray collision point. Get collision point distance to ray global position. So if you think about what this is doing, it's going to return the collision point of the raycast, the distance of the collision point to the origin, which is the beginning of the raycast. So it's going to give you the distance basically from the beginning of the raycast to the point where it collided to something. It's going to give you the distance in between the two. Let's go back to this one. So make this variable, do it ray collision to origin, which is that function we just made. Put the above head ray in there, and then it's gonna do this. If it's gonna check how far along, basically it found something colliding. So if these numbers are specific to my dimensions of the player character body's collider. So if you have different dimensions than the ones I showed you earlier, you gotta find your own sweet spot of what you want to be declared as standing, what you want to be considered as crouching and prone, and all that. But if you're following along with mine, just put these numbers in. If you have the same dimensions as everything else I showed you, then this should work. So if the distance of that is 34, it's gonna be standing, and then if it's anything else, just return standing. I'm outside and there's like some bugs, man. The sun is beating on me. That's good. Makes me go faster because it take way too long to describe these things. Sorry. Trying to make it as clear as possible. I know this is like my first video and I don't code much, but hey, if it works, it works. If you need to pause the video at any time to, of course, pause the video or just copy the code. There's no shame in copying the code, guys. There's no shame. You can learn that way as well. Alright, so just put this function, get above head, do that. Now, make this function, get ledge, return string. Again, I'm gonna update this in a future video to return enum instead, but we'll do strings for now. This one is checking if that ledge up ray is colliding. This is the variable we declared on top. If it's colliding, use this function again like we did right here, except you put the ledge up ray in there as the parameter. Again, these numbers are specific to, these numbers only work basically if you use the same values that I used in character body. If it's greater than or equal to 17, you put crouch. If it's 8, you put prone. And let me see here, I put if it's not colliding, you just put stand. And then I did return empty if it's anything else that's not useful. So just copy that down. Forget about this function for now. Forget about these two functions. Leave that. I'll show you this function right now. This is meant to be a corner correction function for when you're jumping. Alright, so I'm editing the video, and that other function for the ceiling corner correction is not good. It has like a bug in it, so you gotta have this one instead. I only changed a few things, but just get this delta physics time. If test move vector 2 0 velocity y, it's gonna check up, and then if it does, checks in the range of whatever amount you put here, and then within that one another for loop checking in either like left or right because it's on the X. And so then it does another test move, and it's going to see if it's not colliding at I, which is one of the amounts that you put here, times J. So that's going to get the direction. And then just checking up again translates you depending on which I it got. And then this is for, because I went back to the video, and this is for if you're moving into the corner, it'll fix you. And then just return. And that should work. If you click, I don't know if you guys knew this, if you click Control, and you click over a function that Godot has built in, it'll take you to the documentation of that function. So, test move returns a boolean, and these are the parameters. It has a lot of parameters. Some of them are optional. As you can see, this one is optional. This one is optional. This one's optional. So the only one that's needed really is the from. Jeez, there's a huge mosquito over here. Should I kill it, guys? Should I kill the mosquito? I don't want it stuck in my head. I don't think I got it, guys. I tried. Alright, so yeah, this is what that function does. You just need from is basically position and then where it's going. And yeah, this is what it does. It checks for collisions without actually moving the body. Basically, test move. It's a good name for it. You don't have to move the body to test it, but it's like as if you did move the body, and it's gonna report back collisions that happened along its route, defined here in motion. So that was a terrible explanation, but this is gonna do the corner correction for us when we're moving upwards, aka when we're jumping. Alrighty, and let me show you this function, easier function. Set hitboxes. This is gonna set the hitboxes to those. I'm not sure if you remember those resources we made earlier in the beginning of the video. We made the standing hitbox, the crouching, and the prone collision boxes. I'm sorry. And just copy this down. Pose string. Again, I'm gonna change this later on to be enums, but right now we're using strings. So set hitboxes. Pose is gonna be a string. Match pose. So there's gonna match whatever you type in here. It's gonna be one of these, or it should be one of these. Sorry. So if you put stand here, it's gonna do this. It's gonna set the standing shape and then the position, move it down the correct position. These numbers are specific to this project. They are corresponding to how tall I made the colliders and everything. So yeah, if you're following along, then these numbers will work fine. But if you have your own values, then you gotta find out your own numbers. Right here we got the crouch, prone, and ledge. So the ledge is not gonna set the hitbox. Well, rather it's gonna set the position of the raycast because I thought it'd be simple to put it here. It's gonna move the raycast to the right or to the left, depending on which side your get next to wall is colliding with. So just copy this down, and then I'm going to show you the here, I'll do this real quick. Camera peek. This is going to make your camera do like a cool thing where it follows your mouse slightly. I haven't really completed it yet because the character is able to go out of the screen if you're going too fast. I'll add a video later on to update this, but so far this works somewhat. Follows your mouse around, but it keeps the player in, so it's very simple. Just get local mouse position, target position equals this, and then do camera dot position equals target position. Very simple. Call this function here in the physics process function. Call it down here. And then, if you want, you can copy this function as well. Rotate sprite to floor. This is, I'm not going to keep this ultimately because the sprite that I have right now is for demo purposes, but if you want to have your sprite rotate depending on the floor angle, you can copy this down. Copy this down. If step raise under, dot step under is colliding, then rotate the sprite and do this weird calculation. If you just do get collision normal, it won't work because it's not the same as a rotation vector. So do dot angle, and then that's not gonna work either. It'll make it parallel to the floor. So you gotta do this to make it perpendicular to the floor. It's a lot of math words, but I use ChatGPT for this one, and and then if it's not colliding, you just set the rotation back to 0, so he's up straight again. Again, copy this down if you want to rotate your sprite according to the angle of the floor, and then call that in the physics process function again. Just call that every frame. And yes, so now I'm going to show you the stair-stepping function that I found online. Again, I didn't create this. This is a genius of a guy just created this function and I copied it. I'll post a link to the video in the description. Again, I'm posting a bunch of links that I used to help me create this character controller, because I couldn't have done this on my own. This is when I first started coding, so I didn't know anything. Alright, but the original, just to let you know, the original video for the stair-stepping function is for a 3D game. I altered it to work in a 2D game, so that's what it is. So, the first function you're going to need for the stair-stepping to work is this function. This is the smallest function that I have right now for that. It's called is surface too steep. Put the normal in its vector 2 inside the parameters, and then it's going to return boolean, true or false. So it's going to return the normal, which you set here, dot angle to vector up, and it's going to return if it's greater than self dot floor dot max angle, which this is a property of the sorry guys, it's getting comfortable here. This is a property of the character body 2D node, and right now mine is set to 45 degrees, right? So it's gonna return, this function just returns if the floor or whatever normal you're checking is greater than the floor max angle, and that is, yeah, directly associated to whatever you set this to. Remember that. So copy this function down. Let's move on to the next function that we're going to use for the stair stepping. So let's go right here. Func run body test motion. It's going to have parameters from transform 2D, motion, vector 2, and the result equals null, because that's going to be optional, and return a boolean, true or false. As you can see, this is kind of similar to that test move function that we saw earlier, but we're going to be using a function called body test motion from the physics server 2D class. And just, you know, I'm getting ahead of myself here, just do this. If not result, then result equals this. That's motion result 2D new. Var parameters 2D dot new. You know, make sure you're copying all these little words. Params dot from equals from. Params dot motion equals motion, and that's just setting the parameters of this dot new that you created here to these parameters that we will be setting dynamically whenever we call the function. And it's going to return the body test motion. Yeah, so this function uses the RID of whatever node you call it from. In this case, we're calling it from the, you know, our character body 2D node. Remember, this is still our player script, which is connected directly to the character body node. And so it's going to use the RID of this node, and then the params, and the result is these things which we set here. Okay, so copy this function down, right? And then we move down. We're going to move to the functions that actually do the hard work here. So this is going to snap down to the stairs. So this is gonna be when you're walking down the stairs, it's gonna snap you down. Instead of you floating over the edge of the stairs, you go down, straight down. If there's the stairs, it's gonna return void. Make these variables did snap. Set it to false. Set it to boolean. This other variable, floor below, is a boolean, and it's going to check this here, right here. It's going to check if the step raise, step under is colliding. Now remember, before we go ahead with this, let me just say that, come back up to the variables really quick, okay? Remember to copy down all these variables. If you haven't copied them down, I'll show you them again. Just copy these down, pause if you have to, and move it down. Copy these down, move it down again. Copy these down, move it down again. Copy those down, okay guys? So, but what I was gonna say was that the max step height. So this, if you're following along, just type it like this. If you have your own parameters, if you have your own dimensions for your character body, you're gonna have to play with this number, and it might take a little bit of fidgeting with the functions I'm about to show you. But I'm just mentioning this because this number corresponds to these raycasts right here. Show you. So step raise. Remember, the step under ray is the one under. It has to be longer than the max step height. This one's 16, okay? And then the step forward ray also has to be longer than the max step height. This is 13, remember? And the max step height was -12 in this project, okay? So just remember, those two raycasts have to be longer than this. I just have to mention that. So let's go back down to the functions that will get us to snap to the stairs. Okay, so this is the snap down or stairs check. Create these variables, did snap, and then the floor below is going to check that step raise under if it's colliding, and if it's not too steep, using this other function that we created a few minutes ago. It's going to use the step raise get collision normal as the parameter. And then it's gonna make this other variable was on floor last frame, engine.getPhysicsFrame minus last frame was on floor equals 1. So this is just checking if you were on the frame, if you were on the floor last frame. Because if you do this, get current frame minus the last frame you were on the floor, and if it was on the floor last frame, then there should only be one difference in between them, essentially. And that's what this variable is. And then we're going to do this. If not is on floor. So if you're not on the floor, and the velocity .y is greater than or equal to 0, which means if you're going down, because in 2D, negative y is up and positive y is down. Remember that? So this is for 2D. And so if you're not on the floor and you're going down, because this is right when you step off the edge of the stairs, okay? So right when you step off the edge of the stairs, you're going to be not on the floor, and you're going to be going down because you're about to fall off the stairs, the edge of the stairs, I'm sorry. And was on floor last frame or snapped to stairs last frame. This was declared at the top of the script, I believe. And floor below. Okay. So this one is right there. This one is on the top, and this one is right here. And then so, wow, my head is freaking hot, guys. It's the sun. Wow, the sun is super bright today. Okay, we keep going. So, copy this down, and then do bar body result equals another one of these, just like we saw in the we're gonna do that new again, and then we run run body test motion. So we're gonna use this function here to do the we use our own global transform, and then what this is checking the y. So it's gonna go minus max step height. So since our step height is negative already, doing a negative here is gonna make it positive, which makes it go check downwards. And then this is the test result that we have here. It's gonna store the results, I believe. And so we create a new variable if this is true, you know. I think this is only true if it collides, I believe. So if it collides, we make translate y. Get travel, I believe what this function does, it comes with Godot, obviously. What this does is it gets the point of collision right before you collide. So it prevents you from getting stuck inside the thing. See right here, get travel. Returns the moving object's travel before collision. Yeah. So that's gonna help you teleport your player to the correct spot. So here we go, self.position.y plus equals translate y. That's gonna move you down. Apply floor snap. I believe this is a built-in function from the character body node. Set did snap to true, and then snap to make, and then move this back here to this rank, and do snap to stairs last frame equals snap. So this snap to stairs last frame was a variable that we declared at the top of the script. Set that here. Okay. This should now snap you down successfully. But now we have to make the function that snaps us up the stairs when we're walking up the stairs. So we're going to do that right here. Snap upstairs check delta boolean. Turns a boolean. So in the original tutorial he has this line here, which is basically gonna this prevents this function from working if you're floating in the air. Basically, it doesn't allow you to snap up this height if you're in the air. This would only allow you to snap if you were on the ground already. But for my game, I felt that having this kind of corner correction thing happen if I'm jumping, onto a ledge, for example, I felt that it would be nice to have, so I just took it out. But if you don't want this to work when you're in the air, then keep this. Write this down. Write this line down. If you want it to work only when you're on the ground. So, it's gonna check. If not, if you're in the air and snap the stairs last frame, then return false. And this whole function won't work. But I took it out because I want my character to, have this behavior. But I took it out, so I'm gonna start with this one. If I made this variable myself, because it works. It helps. It's pretty glitchy when you jump and you don't add this. So just put this here. If ignore stair step for jump. If that's true, then return false. And then we're gonna move down. So var expected move motion equals self.velocity times vector 2 on the x, and the y is 0. So right now we're just checking the x on this variable. Now, step pause with clearance equals global transform. Again, I'm gonna send the video that I got this from in the description because I didn't make this function and I'm not smart enough to even know everything that's happening here. So you guys can watch that video if you want a more detailed explanation, but for now, you could just copy this stuff down, you know. Pause it if you want, just copy this stuff down. This is checking expected move motion, so this is gonna send you up, and step height up. Yes, so since the step height is negative, it's gonna check upwards, and I mean negative because when I declared it at the top of the script, it's negative. So this is gonna check upwards, I believe, and then this is the down check result. You create a new physics test motion result, new. Then we're gonna use the run body test motion again, but this if statement is kind of long. So if run body test motion, step pause with clearance, vector 2, 0 on the x, and then negative max step height on the y times 2, which is gonna, since it's negative here, it's gonna end negative on the top. 2 negatives equals positive, so this is checking downwards. This is gonna check basically, so this one made it move upwards. This goes translated upwards. And then this one makes it check downwards. So this is checking if there's a stair that you step on in front of you. And then the down check result is, and it's checking if down check result is static body 2D. You can put whatever you want here, but my test world is made out of static body 2D, so this works for me. You could use tile map or something like that, but whatever you have. And just to make sure you see this, this is one whole if statement. You just put the and on another line, which is fine with the Godot engine. And then, you know, write this down, and then if that's true, you make these variables step height. This is going to be how much you're going to move your character upwards to get to the top of the staircase. If step height is less than the max step height, or step height is, you know, he said that adding this would prevent some glitchiness from occurring. If the step height is too small, it'll glitch out apparently. So if it's good with the step height and the step height is not too small, or down check collision point, I'm just checking the step height again, I believe, return false. So that if any of these come to be true, then we stop calculating all this check the steps. And then here we do, yeah, so here we're moving the step forward raycast to the collision point, and we update the raycast. And then if we check if it's colliding, and if surface is too steep, if it's not too steep, then we essentially move the player up the step. This is where the actual stair stepping happens. Copy all this stuff down, guys. I'm not qualified to explain all this. Apply floor snap right after you move the player's global position, and set snap to the stairs last frame is true because we just snapped. Then return true, because that's how this function is working. He's gonna return true if he snapped, and then move this back, you know, to be in the last rank here, and then return false, because that would mean that if any of this didn't go through and it didn't return true, it's gonna return false, meaning it did not snap. So now that we have those two functions, we are going to call them up here. We're going to call them in the physics process, and the way you call them is just like this, guys. Go down. So you put if not snap upstairs delta. If not snap upstairs delta, move and slide, and then after move and slide, snap down to stairs check. He explains it in the video, saying that this is a good setup to prevent some glitchiness from happening. So just write it down just like this, guys. Again, I'm gonna put that guy's video in the description because I ripped that guy's functions right out of that video. He did a great job though, because it works flawlessly. So far, I can tell. Okay, okay. So this, guys, is basically it. I'm gonna put this. Actually, I'm gonna show you guys two more functions. Make the input function. This is the Godot's built-in input function. It just comes like this. As of Godot 4.3, if you type in func input, it'll auto-complete all this for you. Event, input event, up to void. Then in this input function, we're gonna put if input is jump, just pressed. We're gonna make this variable true. Okay, and then right after it's pressed and it becomes true, you create a timer. You put a wait timer.timeout. This is the time of that. And then after the timeout is done, because the wait makes it wait for this timeout, and then after that is done timing out, it makes it false again. Again, this variable is just used here. Where is it? If that variable is true, this function will not run, and that prevents glitchiness from happening. So that if you're jumping, it allows you to jump without doing the upstairs check, snap upstairs, because basically, if you don't put this ignore stair step for jump, it won't let you jump. It'll just snap you down. We don't want that. We want to allow the player to jump. See if I'm still. And okay, so that's all the functions that you need right now, I think, for the player script. So now let's move on to the actual states themselves. So let's go to the idle. This is the first state that you're gonna be doing. You can copy all this down if you want. So just to clarify, let's go to the states scene. Remember, the states scene has all the nodes of all the states. The root node is just called states, and the root node has a script which just references all states, creates a name for them, and these are accessible within the other scripts. As you can see, return states.move, that is referencing this move right here, which is referencing this node, which will in turn return all of this. And remember, we're calling this update from we're calling it from here, current state dot update. So on the current state, we're calling this, and this is just checking what state should it be in. And remember that this is being instantiated here, under, as a child of the character body now. Okay. So with that in mind, I'm gonna show you the states themselves. Each of these scripts down here, not this one, not the root node, but all of the ones under it, idle, move, fall, jump, etc., they extend state.gd, and you have to put the state.gd script, which was this script that we made, put it in the, remember, it has to be in the same folder as all the other scripts and in the same folder as the states scene itself. Okay, just put them all in the same folder and it should work fine. So come back to the idle state. The idle state is the first state that we're gonna set, that we already set in the ready function of the player script. And so yeah. Oh, one more thing. At the player script, forgot to mention, create this function, gravity. We're gonna call this in some of the states. So if jump hang Right. Gravity equals jump hang gravity. If velocity blah 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 else, and do this at the bottom. Velocity dot y times physics times time. Okay. This is important. We're gonna call this many times. Okay. So back to the idle. Like I said, call player.gravity. Here we're gonna do some checks. So you could just pause the video and copy all this, because what we're doing here is checking if certain conditions are met, then we put you in a different state. For example, if your player is on the floor, and if the movement input, which is set in the player script, is not 0, which means if you're pressing a key, or your velocity is not 0, which means you're still moving because of friction or whatever, then we return states.move. And then down. If we're not on the floor and your velocity.y is greater than 0, which means you're moving downwards, because in 2D up is negative, down is positive. So if we're moving down, we return fall. Okay. Now down. If player.crouch input return states crouch. This is from the player script, which is why everything obviously that says player dot is coming from this script here, the player script that we were messing with a few minutes earlier. So, if player crouch input, return crouch. If player jump input actuation, if player can jump, return states jump. If player dive input, dive. Player test, down. You can actually ignore this for now. I still haven't finished implementing that. But you can add these two. If player above head, this just makes it so that if something is moving above you, and it forces you to crouch or prone, depending on how tall it is. And always return null at the end of these update functions. In all of them, always return null, as you see. So then in the enter state, func enter state, do set hitboxes stand, and then this is my animator. I have it set to idle. This is an animation that I made. You can have your own animations if you so please. Now I wanted to show you this real quick. So can jump. Let's go back to the player script. Hopefully for the last time. Can jump. We'll set it here in the process function. What I'm looking for is this. So this kind of works for now. So just copy it down. This is gonna set can jump to true or false, and the jump count, depending on if you have coyote or if your jumps are over the max jump count. If you get next to a wall, you can always jump. If you're on the floor, you can always jump. So just copy this section down. Remember to put it in the func process. Okay, now that we got that, we're good. Come to the move. The move script. Remember, all these scripts that we're looking at have extend state.gd, and they are children. The scripts are corresponding to their nodes here. So this is the idle script, this is the move script, the fall script, so on and so on. And these are the nodes that are again referenced in this node here. Just to make sure you guys remember that. So let's go here to the move script. So state.gd extend func update, call gravity, and also call player movement. That is coming from the state
Remember, it's gonna handle left to right movement. So call these two in the top, okay? And then this, you don't need this. This is for the animation to speed up or slow down, depending on how fast you're going. But forget about that one for now, and just look at these. So, if player crouch input, return crouch. If player velocity dot x, so if you're not moving sideways, and player is not down, return states idle. If player dot down, return down. I haven't finished implementing downs, so you don't have to add it. But do this at least. If velocity.x equals 0, return states idle. If player.velocity y is less than 0, which again, remember, means that you're moving... Wait, no. Player.velocity is greater than 0, means you're moving down. So we're moving down, and you are not on the floor, and get next to wall is not null, which means there's a wall. And if you press in the same direction that there is a wall, so if you're pressing right and the wall is to the right, you will enter the climb state. So essentially you have to press the right key or the left key depending on which wall is present to actually climb that wall. It won't enter it automatically. You have to press the key which corresponds to the wall sign. That's what that's for. If you don't want that function, just remove this line and it will automatically put you into the climb state as long as there's a wall next to it. And then we put, and then if there is, so that what does this do? If the wall is null, then it just returns falling. And then if player jump input, if player can jump, return jump. If slide input, just return slide. If dive input, return dive. Remember, the dive and slide was set in that weird function that we had down here. Wow, where is it? This one. This is for the slide and dive. Okay, remember that. We were in move, yeah. So set these, and then if this is the down input, you don't need that again. And then the crouch and prone, return null if nothing happens. And set the hitboxes to stand in enter state. Now, let's move down to the fall script. Extends state GD, of course. Make these variables. There is a jump buffer that I had implemented, but it was not to my satisfaction, so I'm gonna be updating a video with that. But for now, create constants, jump coyote duration and jump hang time. The coyote duration is what coyote is. Everyone probably knows that if you fall off a ledge, it gives you this amount of time to press jump again so that you can jump even if you're not on the ground. So you can jump if you just fell off a platform, you can jump for a short amount of time. It gives you like a grace period. And the jump hang time is it hangs you in the air for just a little bit so that you can get some extra control over your character. So when you're at the top of your jump, it hangs you there for about, 0.1 seconds or whatever that is. And that makes you feel like you have a little bit more control. It feels more responsive in a way. So make the update function again, always put that delta, call player.gravity and also the player movement. And so we're gonna check if player is on floor and if velocity x is 0, if you're not moving sideways at all, return idle. If you are moving sideways and you're on the floor, return move. If player crouch input, return crouch. So if player to get next to wall is not null, which means there's a wall, and if player input is equal to where that wall is, then return climb. Again, if you don't want this function, just remove this. This feature. What this line does is checking if you're pressing. For example, if the wall.x is to the right, then you only enter climb if you're also pressing right key. And if it's to the left, same thing. You have to be pressing left to enter the climb. If you take out this line, then what this is going to do is just put you into the climb state if there's a wall present at all. Okay, but I like this method better. I don't know, it feels a bit more responsive, less mistakes. But play around with it, play around with it. So here, next input, jump input actuation. If can jump, return jump. This is the jump buffer stuff that I'll show in another video. If slide input, if not get mid raise, return dive. I made it so that when you press the slide input and you're in the air, you can dive. Because I don't want the slide to be accessible from the air. I just felt that it would be more intuitive for the diving to be accessible in the air. But the sliding makes no sense for me to be put in air. So if you're falling, it's the fall script, and you press the slide input, and the mid rays are not colliding, which means that there's enough space for you to become the dive. Then you get dive. And down. Again, you don't have to put that, but these two, yes. Above head, prone, crouch, return null if nothing happened. And gonna do a few things here. Func enter state. Set the hitboxes to stand. If the player dot y is greater than 0, which means if you're moving down, or if this is just for the animation. You can put this for the animation. Yeah, that's just the animation. So put this though. Player.jumphang equals true. Then make a timer real quick. Just get tree.create timer. This creates. I showed it to you earlier, but I forgot to mention. This just creates a timer. Okay. You don't have to create a node for this one. There is a timer node, but this is just a scene tree timer, which is just, it just spawns in whenever you need it. So this is putting in that jump hang time, and then we connect the timeout. The timeout is connected, so when it times out, it's connected to this function, which is this function right here. So after you write this line, make this function, func, and these two things have to have the same name, okay? You're connecting, this function connects this to the function that has the same name. So it has to have the exact same name, and then I'm just setting player jumping as false. So basically when this times out, it's going to play this function, which just does this. Player.jumpHang is false. Remember, jumpHang is used to set the gravity. And add these two things, add these here. If player pre-state is move, player coyote is true. This is gonna set the coyote, and we'll see how that works soon. And then elif pre-state is climb, wall jump coyote is true. I have also a wall jump coyote so that you jump in the direction of the wall, even if you fell off the wall. I'll show you later. And then one more, if player coyote or player wall jump coyote, get tree, create timer, coyote duration, dot timeout connect, and then it's gonna, on timeout, it's gonna play to this function. So write this function down. On coyote timeout, player.walljump equals false, player.coyote equals false. Remember, all the variables that we're calling from player dot are from that player script, that where we put all those variables and all those functions. Okay. So move on to the next one. Jump. So jumping. Extend state GD. Make these variables constant. Release easing. Whatever. Play with that number if you want to. And wall jump. So set it to false. The player. So let's see. Func update. So this is where we call the ceiling corner correction. It's only going to be here. Jump is only called if you're moving upwards and you're not on the floor. So if you jump and you hit a ceiling and there's a corner that you're able to get around, it'll do it. This is the amount of corner correction, the max amount that you want to be allowed. So how far you want the corner to be away from you, that's how far this is. So then call gravity, call player movement, and call this function, which is here. Make this function func handle jump released. Player.jump just released. If wall jump. So if wall jump is true, then you do this. And if it's not true, it won't do that, but it will always do this. Velocity.y. This one is velocity x, and this one's y. So make sure you see that. And then after we make wall jump false. So come back up, func update. Remember you called these already. So now this is animation stuff. Don't need it for now. And then here we're doing if velocity y is greater than 0. So if you're moving down, return fall. No, so if you're moving down, return fall. If player get next to wall is not null, which means that there's a wall, and if movement x is equal to wall x, return wall run. I haven't finished implementing wallrun. If you wanna try and fix it, you can type this. But if you don't wanna mess around with wallrun, just type states.climb here, okay? Then that's just regular stuff. But if you want to mess around with the wallrun state, which I have, and it's not complete yet, but it's almost there. Just type this in. And what I want this state to be is, since you're jumping, you're moving upwards in the sky, right? You're jumping. So if you get onto the wall and you want to climb it, it's going to put you into wall run, which I'm assuming since you're moving up and you're jumping, you want to keep moving up a little bit on the wall. So wall run is supposed to be like, it moves you up along the wall a little bit and then puts you in climb to give you that little extra boost. I haven't finished it though, so we'll look at that later. If player jump input actuation, if player can jump, turn states.jump. If player crouch, crouch. If player slide, if not, player get this. By the way, this little exclamation point means not. So if player not, if not player get mid raise, then turn dive. Down, you don't need down again. Turn null. You already have this function. So go to func enter state. We're gonna add player.jump count plus 1 plus equals 1. Player set hitboxes stand. If player get next to wall. If player not ledge jump up. This is set in the ledge state. I'll show you right now. We put wall jump equals true. If all these things are met right here. Now come down. If this is not an if. Player.velocity.y equals player jump velocity. You just set that. If wall jump and player get next to wall is not null, so if wall jump and there's a wall, it's kind of redundant, I guess, but just to be safe, we're always checking twice. Check twice, I guess. Player.velocity x equals player get next to wall the x, so it's gonna be either -1 or 1. and then it's going to be times jump velocity. So this is going to make sure you, if your wall jump is going to push you in the right direction. So, and then elif previous state equals fall. So if these things aren't met, then it's going to check if you're in this fall state. And if you're in the fall state and you got the, if previous state was fall, and if wall jump coyote is not null, just write this down for now. I forgot to show you this function, but just write this down. Player.walljump_coyote_dir is not null. Then player.velocity x equals walljump_coyote_dir.x times this. So this is gonna set the direction correctly if you're on coyote timing. And let me show you that real quick. Well, first, just type this: func exit state player.ledgeJumpUp equals false. I'm gonna show you that is also set in the ledge state, but I'll show you right now real quick. Come to the, look, copy this name that you typed here, copy it, okay? Copy that. Now, go to the player script again. Come up here. I just put it above my get next to wall function. This, paste it, right here, paste that. This is a new function, walljump_coyote_dir. If walljump_coyote, return previous wall direction. So that means to me. And if not, just return null, okay? So that's what this was for. If it's not null, then you do this. So here it is again, just copy this down. We're going to be using that, I think only here, but just in case, yeah. Let's move on to the next state, climb. So, extend state GD, make these constants, climb speed, slide speed. Make func update. Remember, every time that this update is called and also the enter and exit state is called, that is coming from this script. Enter state, exit state, update. Remember, that works because we're calling these functions in the player script when we made that whole change state function. And that works from the other scripts because we are extending state GD, which is this. So it all connects somehow. So on func update in the climb script, we are going to be doing do not call player gravity, do not call that. Call player movement and climb movement and delta for that. Now climb movement is right here. Make this function climb movement delta. If player movement y is greater than or equal to 0, this is for the animation. You don't need this, but you need this. If this is gonna basically set your speeds on how you climb when you're pressing up or when you're pressing down, or if you're not pressing anything at all, which is the first one. Just copy this down. I might update this in the future to use move towards instead of lerp, but for now it's okay. So just copy this down, put it in this function, and we keep going up here again. So after you call these two here, we're gonna move down to this if player get next to wall is null, meaning if there's no wall next to you, and if you're not on the floor, return fall. Else, meaning if you are on the floor and there's no walls, and if your velocity sideways is not, if you're not moving sideways at all, then return idle, and if you are moving sideways, return move. Now, the else here corresponds to wall. So, if wall is null, so else is if there is a wall, and player is on floor, and you're not pressing the climb input, then return idle. So this is gonna make it so that if you're on the floor, like, you're in the climb state here, obviously, but once you reach this, if you're not on the floor and you aren't pressing the climb input, then you go to idle. Else, meaning if you are not on the floor and you have this here, if player not ignore ledge, you must put this to work correctly with the ledge state. This is gonna allow you to transition from ledge to climb. If you don't put this, it just won't let you transition, because ledge state also uses get next to wall to get into, so it's a little bit finicky, but I made this solution. It's pretty good. If player is not, ignore ledge for climb. If player.getLedge is empty, well, is not empty, I'm sorry, return ledge. So if you're not ignoring ledge for climb, and if getLedge is not empty, which means that it has something, then must return ledge. So, and we got the simple stuff here: input, actuation, player can jump, return jump. If player slide input, if not get mid raise, dive. If player down, yeah, you don't need this one. And then return null at the bottom. So you have the climb movement function already. Now let's move down to enter state and exit state. So I found that doing this is better. I feel like it's more intuitive, because if you're climbing and you hit your head on the ceiling and the ceiling is sloped, there's a chance that it'll just take you out of the climb state. And I found that it didn't feel nice playing with that. So have this equal false. Set hitboxes stand, and then set hitboxes ledge. That works because they're doing, remember, in the player script, this sets the collision box, and then this one sets like the raycast. So you don't need this unless you have some animations going on. And then down here we're going to create a little scene tree timer, and you do a wait dot timeout, so 0.1, and then player dot ignore ledge for climb equals false. You need this again to work correctly with the ledge state. And then do exit state. Player dot slide on ceiling equals true. So set that back to true, because you do want to slide on the ceiling if you're not in the climb state. It feels better in my case, because I want the movement to be constant, not just moving around always. So that's it for the climb state script. Let's go to the crouch. Yes, crouch. Now the crouch, same thing, extend stage GD. Now this is the func update. Call gravity, and then call player movement as well. If player get above head is stand, and if input is, so this is checking if you can stand, and if you can, and if you're pressing upwards, and if you're not on the floor, you see? If you're not on the floor and your velocity.y is moving down, then you return fall. If you are on the floor and you do press up, you go into idle state. And now, I put all this under stand so that it makes sure you have enough space to actually do this. So if you press jump, then it'll allow you to jump. If you have a stand thing, if you have enough space to stand. And then on the outside of this, I put if action is moved down, or player dot get above head is prone, then you equal return stays prone. This is just if you press down, or if something is forcefully trying to put you into prone by blocking you, then you just go into prone. Now another one of if state, if player is not on the floor, and if there is a wall, get next wall is not null, and if your movement input is .x is the same as the get next to wall direction, basically, return states.climb. Again, we don't need this right now, dot down, but do return null at the end. So enter state, func enter state. Remember, we're in the crouch. Enter state, player.hitboxes crouch. Okay, and then this is my animation. I'm not going over animation in this video. Okay, so I'm just moving myself here. So let's go to the prone state now. Wow, this video is taking a lot longer than I thought, but hopefully it's educational for someone. So extend state GD. We're in the prone script now. So func update. Do player.gravity and then movement, player movement. Now checking if player get above head, which is, remember, this function checks what's above your head and how much space you have. So if it's crouch or stand, that means you have enough space to stand or crouch. But since you're in prone and you press up, it's gonna put you in a crouch. I feel that that's how most games do it. You don't just go from prone to stand. You go prone, crouch, and then stand, and vice versa. You go stand, crouch, and then prone. That's how I have it set up. If you want a different system, you can easily change that around with just these if statements. But that's what this is doing. And then it's also checking if you have enough space to stand, and you press jump, it'll allow you to jump. Now again, we don't need this down right now, but return null at the end. And then do enter state, set hitboxes to prone. Now let's go to the roll state. First, yeah, let's just do roll. I'm doing these out of order, but I'll show you the result right after we finish them, okay? So go into the roles state. Remember, to make a state, you have to make the node as child of states. And remember, it's just a node, regular node, and you would add that here, and it should be here, node. I'm gonna cancel that because I already have them all, but you have to name them what you want it to be, and then you have to add them here. Just recap. Okay, just if you want to make a new state, what if I wanted to make a state that was swimming, right? Add swimming. Go like this, and then do swimming. Oh. And then this would have to be a node over here. You would make a node, call it swimming, and then you would attach your own script to it, right? Just to show you guys. Go back to the roll script. Again, do for all the state scripts, you gotta do extend state GD. Make these constants. My rolling state is a little iffy, but it kind of works. So just copy this and then you can upgrade it. Roll strength, acceleration, time, and roll. These are the constants. Actually, I see like something here I can just do this. So, instead of doing this, just do this. And okay, so rolling true. Okay, now come into the update. Player gravity. Player movement. Now, if not rolling, so it's gonna wait for that to finish rolling. If not rolling, and if player dot is on floor, skip this line. Player velocity is .x is 0, which means you're not moving sideways. Turn idle. If you are moving sideways in any direction, you turn move. Now, this else is related to this, so if you are not on the floor and you're not rolling, turn fall. And this is still under if not rolling, so if not rolling and get above head is crouch, crouch, prone, prone. Okay, got that. Now go get out of the, press back and turn null, just like always. Now,
make this function move toward x. X is string. So var I, okay, match x. X is this. So the only thing you'll be able to type there is moving or not moving. Make it like this. This is pretty iffy stuff, but it works for now. So just copy this down, guys. Moving that I equals, not moving I equals, and then put this outside of the match statement. Player.velocity.x equals this. Now, move down to enter state. Set hitboxes crouch. Skip this one for now. But don't skip this one. Put this. Now, if player velocity x is not 0, which means you're moving, move toward x, moving. Like we said, this is it. And then this one corresponds to this one, okay? So if you are moving, this, else, if you're not moving, type this. And then after that, create a timer, time here, dot timeout, it's gonna await timeout, and once that's done, you're gonna turn rolling into false. So after this time is out, it's gonna send this signal, and this signal is gonna await that signal, and then it's gonna make rolling false after this. And that's all you need for the roll state. Now let's come into the dive state. Dive state is a little iffy as well, but we move on. Extend state GD. Make these constants and these variables and an enum as well. Make it just how you see here. Now, the update function. Once again, player.gravity, player movement. And we check if player's on floor, turn roll. Remember this is the dive state, so once you hit the floor, it's gonna go into the roll. If you hit the wall, return states fall. And yeah, this one is pretty small in the update function, so just return null after if nothing happens. Now we make another function called move toward x, similar to the roll script, but different, quite different. So like I said, this is kind of iffy. I am not too good at coding, but just copy this down. Move toward x, check condition. Condition corresponds to this. That's gonna be one of these. So all those other scripts that I had strings as parameters, I'm gonna change that in a future video to be enums. Because it's much more safe. You only have a few options to choose from, whether as in a string you can do anything. So do this, check, and it's going to be conditioned. So make a variable, float, I is a float, strength is another float, and just do these checks if player velocity is not 0, player.velocity.x is not 0, strength equals blah 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 blah. Just copy all this down. This is just a bunch of stuff that I wrote down and try to make something work. So like I said, it's a little iffy, but you could just, copy it for now. It works enough, good enough. And this is where we check condition, floor, condition area, wall coyote. Set all these I equal, and then at the end of it, do the clamp to make sure you're not going over the edge with the strength, and then set the velocity as well. Now move down to the func enter state. We're gonna do initial velocity equals player.velocity, and then set the hitboxes. Set hitboxes prone. You can skip the animator line, we're not talking about that right now. If initial velocity is greater than or equal to 0, player velocity. Right. If is on floor is where we use the move toward function, the move toward x function. Alright, there's another function called move toward. This is our own function, move toward x, condition floor. This is where we're using this, and this is where it's checking the match statement. So just copy this down, guys. If player is on floor, blah blah blah. If not on floor, blah 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 blah. If on wall, if not on wall, if in the air, basically it's all that's happening. Okay, copy all that down, guys. Pause the video if you have to. I'm gonna move over to the vault. state script. Okay, go to the top. Extend state.gd. Make these variables move time, v move time, h move time. There's an enum and another variable, which is corresponding to this. So the update function is kind of small here too. It's update delta if player is not vaulting, match end on. So I'm gonna show you what this is. This allows you to climb over a ledge into a space. So if the space is enough for you to stand, it'll just have you stand. If the space is small enough for crouching, it'll have a crouch. If it's small enough for you to be prone inside of, it will do this. I haven't seen many games that have this feature, so I don't know how to explain it very well, but it's just that. It's just that when you climb over a ledge, and it'll check how much space there is over that ledge. And depending on that, it'll return one of these states. So just copy this down, and then return null at the bottom as always, and the update function. Now move down to do this, the vault. So func vault, and yeah. So just copy this. I got this from a YouTube video as well. I'll try to find it, put it in the description, so you guys can see that guy's explanation. I believe that my implementation is a little bit different than his. I don't actually remember, but you can look at that video anyways for more explanation. So, move time, age time, blah blah blah. V height, like this. Vertical movement, so player global transform. So this is going to get the origin of where you are, the position basically, and then get the plus the height. So I think that's gonna be how much you vault upwards, how much it's gonna move you upwards, and then this is creating a tween, which is like a animation type of thing. So if player vaulting is true, then we do a tween. We wait until the tween is done. Horizontal movement is going to be the movement of how much it moves you sideways, and this is going to tell it which direction to move you in. So this one just moved you up, this line right here, and so this line is going to find out which direction to move you in, left or right, after it moved you upwards already. So after it moves you up, it's going to move you sideways here, and then that's what this does. It's creating the tween, and then you do the tween, and then you wait for the tween. And once the tween is done, once both tweens are done, basically, makes vaulting false because you're done vaulting. So move down to enter state, func enter state. If player get ledge is not empty, which means that there is a ledge detected, you match which detection it is. So it's going to detect how much space there is above the ledge. That's basically what this is doing. Remember, this function we already set up in the player script. If something's not working for you, it's probably some values, and maybe your collision boxes and all that stuff has a different value than mine. You can either just copy the numbers that I have down from the beginning of the video, or mess around with your own values. Either way, this is what it's doing. Checking how much space you have, and then it's going to set the end on variable to be one of these, which is set at the top there. This is the animator, skip it, but call this at the bottom vault, which is that script we just made here, the function I mean. And then on exit state, we're checking this is experimental. This is just gonna give you a little boost to your speed if you're pressing the same direction that you're vaulting in. I found that it's pretty nice to have this because if you don't have this, your player starts off at 0 speed when he's done vaulting. So you can add this in if you want, but play around with it. Play around with taking it out and adding it back in and see what it's very subtle, but you can play with it for yourself. So yeah, copy that down, copy all this stuff. That is the vaulting state. Now come into the slide state. It's a little bit smaller, so extend state GD, create these variables: constant length, constant time, var sliding. Yeah, I'm gonna do the same thing I did with the other script real quick. This equal true. Okay. So make these variables. Now call the func update again. Call player gravity and then player movement. Now check if not sliding. Player is on floor. You don't have to put this line if down, but we are checking if the velocity.x is 0, which means that you're not moving sideways. Then you return crouch. If you are moving sideways, then you return move because you're on the floor. We want you to go into one of these, and if you're not on the floor, you return states fall. Now, outside of sliding, I wanted you to be able to enter jump even if you're not done sliding, for that extra feeling of responsiveness, right? So, if jump input can jump, jump. Now return null at the bottom. Anything else? Now make the enter state function again and set hitboxes to crouch. Skip the animator slide and go to player.velocity.x plus equals player.last direction, which remember you should be setting that here, I believe. Yes. This is the state script, and we type this in here. Last direction equals whichever one is corresponding, because and then yeah, so velocity.x plus equals last direction.x times length. Then we await the timer timeout and set sliding to false again because we set it to true. So come down into the ledge state. This one a little bit longer. Extend state GD. Now come into the update function. Let's remove this print statement. Now, if player get ledge is empty or get wall is empty, it's null, meaning there's no ledge basically, or there's no wall. And if you're not on the floor, return fall. If you are on the floor, return idle. So now come down, and if player jump input, this is a little different. So okay, so if I'm doing this here so that if you're here we're in the ledge. This is the ledge script, right? And if you're in this state using this script, you're in a ledge state and you press jump. Now, if your movement input is equal to the wall direction, remember this is set in the get next to wall function depending on which wall is present. So if you're pressing right, for example, and the wall is to the right, and you press jump, and you're pressing right, then you're going to enter the vault state, and it's going to vault you over that wall in that direction. Now, if you're not pressing this sideways button, and you just press jump, it's going to jump you off the ledge as a wall jump. So that's how that's working, right? Okay. So come to the next thing down. If movement input dot y is greater than 0, meaning you're pressing downwards, and if you are on the wall, Sorry guys, there's freaking bugs out here, bro. I mean, I'm outside, but still. If you press down, basically, and there's a wall, it's gonna return states climb. So the imagine, I'll show you in game, but you're on the ledge on the top, and if you press down, you go back onto the wall, and as a climber, you climb it. So now, if slide input, return dive, you can skip the down if you want to, but this was gonna be, just so you know, this was gonna be a state where you go down, but you're not dead, you're just like unconscious. I was gonna implement that later on. So return null if anything else. So here, this is the built-in Godot func input. So just create this func input. If you type this in, it should auto-complete the rest of it. And then here I'm checking if input is action pressed move up, then player.ledge jump up is true. Else player.ledge jump up is false. And then also we got if input is just press move down, ignore ledge for climb is true. So I'll tell you what this one does is if you're pressing up and this is supposed to be that when you are pressing up and you press jump, it'll make you jump upwards instead of having you jump sideways like a wall jump. So I just added that to, you know, add some more options, more flexibility into the movement. So if you're on a ledge and you want to do a wall jump, you can do that. But if you want to do a jump that just goes upwards, straight up, you can press up while you're jumping, and it'll make this variable true, which the I don't know if you remember, the jump state will read here, and it won't allow you to put wall jump. So it'll just make you jump upwards. So that's what that's for, and then this one is for ignore ledge for climb. So if you press downwards, ignore ledge for climb. So it'll be because if this wasn't present here, then it wouldn't allow you to get out of the ledge state, because basically the conditions for ledge state and the climb state are very similar. So this just helps you get out of the ledge state and go into the climb state much more easily. And as long as you copied all the other code down correctly, it should be set up in the climb state to read this. So just make sure you have that correctly. Go back in the video if you have to. This is the enter state func now, and then do the player ledge grab collider disabled false. So I forgot to mention, come back here really quickly to the player scene. Look at it. Make this bigger. So that is relating to this. Remember, it's this collider, this line. And I forgot to mention, by default, you have to click this, okay? Disable it. It's not going to be active until we make it active. So disable this. I forgot to mention, disable that by default. And I'm going to show you right now in the script where we're going to enable it. So go back to the ledge state script we're just on. Now that's what this line does. Player.ledge grab collider disabled equals false. The wording is a little bit weird, but that's how it works in Godot. You are setting the disabled property of it to false, meaning that it's not disabled. So this makes it active, okay? So now we are doing this. This is a little weird. So this makes you move downwards. And the reason for that is so that you can snap onto the ledge. Because if I didn't have this, then you would kind of float upwards. But this makes you snap onto the ledge. It moves you down and hits the ledge right there. And since this collider is just enabled, then it will catch onto that collider and it won't let you move past it. If that makes sense. I'll show you in the video demo. I'll start the game. So, you know, add this right after this line. You can forget about this line unless you have an animator or whatever. Set the hitboxes to ledge. Now we're checking if
if we're checking which side the wall is on, and depending on which side it is, you do this. Just copy it down. This is gonna flip the sprite. This is only relevant if you have a sprite, okay? So this is gonna flip your sprite to the correct direction, and once you do that, make the func exit state and do the ledge grab collider disabled true. So meaning the disabled property of the collider will be true, meaning it's disabled again. Meaning that, so as you can see, once we enter the ledge state, the collider becomes active. Once we exit the ledge state, the collider becomes inactive once again. Meaning it doesn't collide with anything, which is what we want. We only want that collider to collide with things when you're in the ledge state. I'm gonna show the down state script for now. You don't need this unless you're trying to mess around with this. You can copy this down if you want to. This was meant to be a state that would allow the character to be downed but not dead. He hasn't lost all his health per se, but he's unconscious. I haven't added the health system yet, so I haven't added this really, but I think I'm gonna add it into the game. So you can copy this down if you want to mess around with that idea. And let me just... Alright, so this is the wallrun script. Like I said earlier, it's almost feature complete, but you could play with it if you want to. It's pretty good. Again, this is a feature which, instead of going directly into the climb state, gives you like a little boost if you're already moving up. So extend state GD because this is a states script. Then make these variables entry force, duration, wall running. Now make the update function, call gravity, call player movement. So I wanted this to be a transitional kind of state. You know, you're not in it for very long. So there's a lot of ways to get out of it. Right here, for example, if not wall running, or if player Y velocity is greater than 0, meaning if you're going down, or if get next to wall is null, or if player velocity.y is greater than negative 186. I did this because I noticed that if you don't add this, then it's gonna go into the climb state when you're already slowed down completely. So doing this makes it so that you go into the climb state, and if you're pressing up, you'll maintain velocity. So put this whole if right here, and then under check if player is not on the floor, and then under check if player get next to wall is not null, means that it is detecting something. Then we're gonna check if the movement input x, either left or right, is equal to the get next to wall x, left or right. We return climb if that's true. If player get next to wall is null, then we return fall. We have the else, which is corresponding here if player is on floor, and if the velocity.x is 0, return idle. If the velocity x is not 0, return move. Then outside of that we have jump input actuation, can jump, return jump. So then the slide input, if not mid raise, return dive. You can mess with this if you want, like I said, then return null. We have the function down here called force and duration. Make init a variable force to float,
and then check if entry force dot y less than 0. Then you're gonna change the force to be entry force dot y times 0.01, and then we, force equals clamp. This is gonna be a maximum value, and we're gonna have it. This force is gonna shoot us upwards, so that's why it's negative. In 2D, Godot, negative is upwards. And then duration, absolute entry force dot y times 0.01. Absolute, just make sure it's always positive, it never returns negative. Duration, clamp it again, something manageable. And then add the player velocity dot y plus equals force at the bottom of this function. So now that's that function. Then we call enter state, we declare it, I mean, and entry force equals player dot velocity. Don't need that. Player hitboxes, stand, and then right after do the ledge, and that's fine because this is gonna set a collision box and this is gonna set a raycast. And if you have an animator, run it right here, and then after that call the force and duration function. And then after that, still here in the enter state function, call wall running is true, and then await the timeout of this scene tree timer. And once that's done, through this duration, wall running is false. And then make the func exit state and make wall running false again. And that's it for the wall run script. So before I show the game running, I just want to make sure that you guys have this down correctly. So I made a mistake earlier in the video and I put some text on the screen, but I'm just mentioning it again just so you guys have it right. In the slide state slide script, make sure you have this just like this. I set it to true earlier, but that was a mistake. Just have it like this, and then on this line right here, line 30, make sure you have sliding equals true, have the timer, and then await the timeout and make it false, okay? And then I did something similar with the rolling script. Make sure that this is here just like that, and then at the bottom in the enter state function, make sure you have this here, and then another, same thing, a timer, and then make it false again. Alright, so I'm gonna show the game now. And I'll show. Okay, so as you can see, you can move sideways by pressing left or right, and that word in the bottom is the state that you're in. So climbing works. You can go up and down. You have to be pressing the button. See, if I get next to the wall and I don't press the button, it doesn't enter climb state. But then now, yes. There's wall jumps. It'll shoot you sideways. You can also wall jump without being in the climb state. You just get next to the wall. And then if you come up here, you're in the ledge state. There are some the ledge state is still a little bit buggy in the way that you enter it sometimes, but for the most part, if you're not going too fast, it lets you. That's the whole thing. If you're going too fast, it's a little bit buggy, but you can vault. That's what the vaulting state is for. It's right after the ledge, and you can go on both sides. And from the ledge state, you could, let me see, you could jump upwards by holding up and then jump, or you could just do a wall jump, and that's just by pressing space normally. The wall run state is that little slide that you see him do up the wall before he enters climb. It's kind of working how I want it to so far, so I'll probably, I don't know, I'll probably have some changes to it in the future just to make it a bit more polished. And let me try to show the coyote timer. So I'm gonna try to jump off this ledge and then try to jump while I'm already in the air. So see if you can see that. I'm not sure if you saw that. It's I have to lower the value, I believe, but it's there to help you. You see there, I couldn't do it. I took too long, but if you don't take too long, you can just jump off and do that. There's also a coyote for if you fall off a wall. Let me see if that still works. Yeah. So if you fell off the wall from climbing and you press jump midair, it'll give you the coyote grace period, and you'll have that same wall jump in the same direction that it should have been in. And there's not much else. There's the dive and roll state right here. You can dive, and then once you hit the ground, you roll. There's a few weird things with that state, but you can find out about it. There's a sliding, you know. Then, as you saw right here, this is the stair-stepping functions at work. You just pretty cleanly teleports you up the stairs and also down the stairs. Yeah, I'm planning to add some animations to that so it doesn't look so jittery, I guess. But for now, it's perfectly, the base function is there. And remember the stair-stepping function, the way that I have it set up is that it also works mid-air. So if you're in the air, you can still, you know, it corrects you. Let me show the corner correction for the ceiling. So that's only activated here when you're jumping. So you hit your head, you move it a little bit to the side, it'll push you. Don't know if you saw that. Let me show you for the left side. Yeah, it works. There was a bug that I had where it wasn't working on the left side, but if you copy that code that I told you, it should be good. And yeah, so everything is working. You know, there's a few bugs with these scripts. I've gotten rid of most of the bugs, but you know, I'm not a pro. So if you have any ideas or questions or anything like that, just let me know in the comments. Hope you guys liked the video, and thank you for watching.